Welcome to the fascinating world of computer science. This field has revolutionized our lives in countless ways. From the smartphones we use to the software that powers our businesses, computer science is everywhere. But what exactly is computer science? In simple terms, it is the study of computers and computational systems. It encompasses the design, development, and analysis of software and hardware. The roots of computer science can be traced back centuries, with early pioneers like Charles Babbage and Ada Lovelace laying the groundwork. However, it was in the 20th century that the field truly blossomed. Today, computer science is a vast and ever-evolving discipline, with countless subfields and specializations. From artificial intelligence to cybersecurity, the possibilities are endless. At its core, a computer is a machine that processes information. It takes input, manipulates it according to a set of instructions, and produces output. Imagine a chef following a recipe. The ingredients are the input, the recipe is the program, and the delicious meal is the output. But how does a computer actually work? The key lies in its ability to represent information using binary code, a system of zeros and ones. These binary digits, or bits, are like tiny switches that can be either on, 1, or off, 0. By combining these bits in various ways, computers can represent numbers, letters, images, sounds, and more. These representations are then processed by the computer's hardware, following instructions provided by software. The interaction between hardware and software is what allows computers to perform such a wide range of tasks. It's a beautiful dance between physical components and logical instructions, all working together in perfect harmony. To understand how computers work, it's essential to delve into their hardware. Think of hardware as the physical components of a computer system. These are the tangible parts that you can touch and see. One of the most crucial hardware components is the motherboard. It acts as the central nervous system, connecting all other parts of the computer. Like a bustling city center, data travels across the motherboard through intricate pathways, ensuring seamless communication. Next, we have the Central Processing Unit, CPU, which we'll explore in detail in the next section. For now, think of it as the brain of the computer, responsible for executing instructions. Other essential hardware components include memory RAM, which temporarily stores data being used by the CPU, and storage devices like hard drives and solid-state drives, SSDs, which provide long-term storage for data. Input devices, such as keyboards and mice, allow us to interact with computers, while output devices like monitors and speakers present us with the results of our interactions. Together, these hardware components form the physical foundation of a computer system. The CPU is often referred to as the brain of a computer, and for good reason. It's the component that fetches instructions from memory, decodes them, and executes them. This process happens at an astonishing speed, with modern CPUs capable of billions of cycles per second. Imagine a conductor leading an orchestra. The conductor follows the musical score, instructions, and directs the musicians, other hardware components, to produce beautiful music, output. The CPU's architecture is incredibly complex, but at a high level, it consists of several key units, including the control unit, which manages the flow of data, and the arithmetic logic unit, ALU, which performs arithmetic and logical operations. The speed and efficiency of the CPU significantly impact a computer's overall performance. Faster CPUs can process information more quickly, leading to snappier application loading times, smoother multitasking, and enhanced gaming experiences. Just like our brains rely on memory, computers need a place to store information both temporarily and permanently. This is where memory and storage devices come into play. Memory, also known as RAM or random access memory, is like a computer's short-term memory. It stores data that the CPU is actively using. Think of it as a whiteboard, where the CPU can quickly jot down notes and access them instantly. Storage devices, on the other hand, provide long-term storage for data, even when the computer is powered off. This is where operating systems, applications, and our files reside. Hard drives and SSDs are common examples of storage devices. The amount of RAM and storage space a computer has significantly impacts its performance and capabilities. More RAM allows for smoother multitasking and better handling of demanding applications, while larger storage capacity provides ample space for our growing digital libraries. While hardware forms the physical foundation of a computer, software is what brings it to life. Software encompasses all the instructions that tell the hardware what to do. It's the invisible force that transforms a collection of electronic components into a powerful tool. Think of software as the sheet music for an orchestra. Without it, the musicians wouldn't know what to play. Software provides the instructions that dictate how the hardware should operate. There are countless types of software, each serving a specific purpose. Operating systems, like Windows and macOS, manage the computer's resources and provide a platform for other applications to run. Application software, such as word processors, web browsers, and games, allows us to perform specific tasks on our computers. These programs interact with the hardware through the operating system, enabling us to write documents, browse the internet, and immerse ourselves in virtual worlds. Section 7. Programming languages. The art of communication with computers. But how is software created? This is where programming languages come in. Just as we use languages like English and Spanish to communicate with each other, programmers use programming languages to communicate with computers. Programming languages provide a structured way to write instructions that computers can understand and execute. These languages have their own syntax and grammar, just like human languages. Popular programming languages include Python, Java, C++, and JavaScript, each with its strengths and weaknesses depending on the task at hand. Some languages are better suited for web development, while others excel in data analysis or artificial intelligence. Learning to code is like learning a new language. It requires patience, practice, and a willingness to embrace logical thinking. But the rewards are immense. With coding skills, you can create your own software, automate tasks, and bring your digital ideas to life. Section 8. Algorithms, the heart of problem solving. At the heart of every computer program lies an algorithm. An algorithm is a step-by-step procedure for solving a problem or achieving a specific goal. It's like a recipe that guides the computer through a series of instructions to produce the desired outcome. Imagine you want to find a specific book in a library. You could wander aimlessly, hoping to stumble upon it. Or you could follow an algorithm. 1. Go to the library catalog. 2. Search for the book by title or author. 3. Note the book's call number. 4. Go to the corresponding shelf and locate the book. This simple algorithm provides a structured approach to finding the book efficiently. Similarly, algorithms in computer science provide a way to break down complex problems into smaller, more manageable steps. Algorithms are used in countless applications, from sorting data to recommending products online. They are the foundation of many technologies we rely on daily, often working behind the scenes without us even realizing it. Section 9. Computer science in our daily lives. An invisible revolution. Computer science has permeated every aspect of our lives, often in ways we may not even realize. From the smartphones in our pockets to the traffic lights guiding our commutes, computer science is the invisible force shaping our world. In healthcare, computer science is revolutionizing patient care. Medical imaging, drug discovery, and personalized medicine are just a few examples of how computer science is improving health outcomes. The entertainment industry has also been transformed by computer science. Streaming services, video games, and special effects in movies all rely heavily on computer science principles. Even fields like agriculture and manufacturing are benefiting from the advancements in computer science. Precision agriculture and smart factories are increasing efficiency and sustainability. Section 10. Conclusion: Shaping the future. Computer science is not just about understanding how computers work. It's about using that understanding to solve problems, innovate, and shape the future. As technology continues to advance at an unprecedented pace, the importance of computer science will only continue to grow. From artificial intelligence to quantum computing, the frontiers of computer science are constantly expanding, offering exciting opportunities for those with the skills and passion to explore them. Whether you're interested in a career in software development, data science, or cybersecurity, or simply want to be a more informed citizen in our increasingly digital world, a solid understanding of computer science is essential. So embrace the power of computer science and embark on a journey of discovery and innovation. The future is waiting to be coded.